Okay, YouTube, in my last video we introduced the concept of what a parametric equation is and just showed how you could express something in rectangular form instead in parametric form. What we want to do in this video is basically learn how to, if we were given the, say, the parametric form of an equation, how to go back to rectangular form, or we could say defining it explicitly, y equals some function of x, something like that over here. So here's what we're going to do. We're going to follow a set of steps here, and you'll find that these are really just more algebraically intensive in certain cases than they are in terms of, hard in terms of difficulty. So we say eliminating the parameter allows us to represent a parametric equation in its rectangular form, or this explicit form, y equals a function of x. So we say solve for t in one of the equations. We're basically going to use substitution here. So we're going to solve for t in one of these two equations here, and we're going to substitute that into the other equation. What that does is it eliminates the parameter t essentially. So we're going to simplify after that. So down here I'm looking at this, it says, well, and you'll see these, I would like to list it this way also, because you'll see parametric equations listed thusly. We say t squared minus 4, and then this is just t halves. We say t halves. I think it's a lot easier to solve for t in the second equation. So I would say that if I multiplied both sides of this by 2, I would be able to determine that 2y is equal to the time. And so if this is the case, then what we're going to do is we're going to take this, and we're going to plug it back into this equation. Excuse me. And so we get this. We get x equals our time value squared minus 4, where time value is just 2y. So we get this. We really get x equals now 4y squared minus 4. So now, in this case, let's talk about this. I thought it was really easy to multiply both sides by 2 and substitute back in up here. What we're looking for, though, is a function of, y equals a function of x typically, and I've written x equals a function of y. So this time what I want to do is I'm going to go back and I'm going to solve for t in the other equation. We say, okay, well, I've got x equals t squared minus 4, and then we say y equals t squared over 2. So in this case, I would say, well, then I would have to add 4 to both sides, so this would imply that t squared equals x plus 4. And then we would say, we'll take the square root of both sides here. We get the time value is equal to the square root of x plus 4. Okay, and so I'm going to say, well, that's what we get here. Actually, we'll just leave it that way. So we'd say then y. If I were to substitute this in now for y, then we would determine that this would be basically the square root of x plus 4 over 2. And so here we have our explicitly defined function. So now, looking at both of these in rectangular form, let's talk about the merits of both. One way might be easier than the other, and not to say that one is better than the other, but since we often are looking as y as a function of x, this is a little bit easier example, but it is often the case that you'll probably want to solve for the time variable in your x equation, and then substitute that into your y equation, because you'll see how that'll dump an x on the right side of your y equation, and y will still have just a y equals. So just a suggestion. Just a suggestion. I'm only saying that because we're going up here now, and we're going to look at one of these. Now, you'll see these from time to time, and as a matter of fact, they are a little bit more complex in terms of the algebra to deal with here, but what we're basically going to do is we're going to pick one of these to solve for t for, and then we're going to plug it into the other expression. So I'm going to choose, as per my suggestion in the last one here, to solve for t in this equation. So now, this is going to require a little bit of algebra on everybody's part here, but I would say I'm going to reciprocate both sides here. And the reason why is because it's a proportion, and I'd rather have the t variable upstairs if I'm going to solve for this. Actually, I could just write the square root of t plus 1, and we could see that if I were to square both sides of this, so I'm going to square the left side, I'm going to square the right side, it would eliminate that root. And then I think this red marker here, we say, okay, so this would be t plus 1, our parameter plus 1 is equal to 1 over x squared is how I'm going to write that. And then I would subtract 1 from this, okay? So if I subtracted 1 from both sides, we basically are able to determine that t is equal to 1 minus x squared, or sorry, 1 over x squared minus 1. So here's our parameter t. What we're going to do now is we're actually going to go substitute this in for t up in the second expression. I'm going to take up all this space down here. We're going to need a little bit of space. We say t over t plus 1. And what we get here is this expression. We get 1 over x squared minus 1, and this is 1 over x squared minus 1. My favorite thing that happens first is that these 1's cancel out. So now I'm going to rewrite things for the sake of just, kind of clearing this up for everybody that's tuning in on this. This is all over 1 over x squared now. And I'm going to say this is a monomial divisor, which means we can divide both of these terms on the top individually by the basement here. And so I only say that because if you were to take 1 over x squared divided by 1 over x squared, you just get 1. And if you were to take 1, which is a negative here, we say minus, 1 divided by 1 over x squared, well, you multiply by the reciprocal, and so the reciprocal of 1 over x squared is x squared, and anything times 1 is itself, so we just get x squared. So in the long term, in the long run, what I'm telling everybody here is basically this parametrically defined equation, we could have defined it rectangularly as some parabola that opens downward with an a value of 1 and has been shifted 1 up in the air from the origin. So it's just that this is really good up here because we're defining it as a function of time. So anyways, in the next video, we'll keep working on how to change from maybe rectangular form into parametric form going the other way around. Cheers.